Hi, in this video we're going to find the area segment formed by a chord. So a chord is basically any line that cuts a circle at 2 points, typically not the diameter. I'm going to look at how we can find this area here. In order to do this, you need a couple of key skills. That's first of all how to find the area of a sector. So the area of a sector is basically this whole area. And we also need how to find the area of a triangle that's not right angled. So formula for that is a half AB sine C. So make sure you find with both of those. Okay, let's go through this example. So here I want the area of this shaded segment here. The way we're going to do that is, first things first, we're going to work out the area of the sector. So it's basically everything. And then we're going to take away just the triangle. And then what we're left with is going to be this shaded region here. So let's quickly label both these shapes. So that's 85 and that's 4, and this is 4 and 85. Again for this question, because these are part of a circle, both these lengths are going to be radiuses, which means they must both be the same. So both these lengths are going to be 4 centimeters. Now let's work out each of those two shapes. For the sector, we're going to use the formula that we need the area of a full circle times what fraction I have, and for the triangle we're going to use a formula a half AB sine C, where A and B are my two lengths and C is my angle. Okay, let's go through this. So here, if I had a full circle, I would use the formula pi r squared, and in this case the radius is 4. Then I need what fraction of a circle I have, and we have 85 degrees out of a possible 360. So if I times all that stuff together, that will give me this area here, which is basically everything. Next, I need to take away just the triangle. So triangle is a half AB sine C. So that's a half times 4 times 4 times sine of 85. Okay, and then all we need to do is work that out. There's no reason why you can't just type that into a calculator in one big go. So let's do that. So pi times 4 squared times by this fraction here. And then from that we need to take away the area for the triangle, which is a half times 4 twice, or times 4 squared, times sine 85. Press equals, and that gives us our shaded region. And I think this question wanted it as 3 significant figures. So this 3 significant figures is going to be 3.90. Again, it's an area, so that would be centimeters squared. Okay, let's go through that basic idea again. So we have roughly the same setup, and we want this shaded area again. So the way we do it, first we're going to find the area of the sector, and then we're going to take away the area of the triangle. So what we're left with is going to be this shaded region here. Let's quickly label those, so 2 8s and a 40. So for this shape, to work out the area of the sector, I need the area as if it was a full circle, which is pi times radius squared, in this case 8 squared, times by what fraction circle we have. So 40 degrees out of possible 360. We then need to take away the area of this triangle. Area of a triangle is a half AB sine C, so 8 times 8 times sine 40. And again, just like before, there's no reason why you can't type it all into your calculator in one go. So let's do that now. So pi times 8 squared times 40 over 360. That's my circle bit, and then we take away the triangle. So 1/2 times 8 times 8 times sine 40. And there we go, that gives us 1.77. Again, it's area, so centimeters squared. Okay, I'm just going to go through 2 exam style questions. That sort of changes up a tiny bit. So here I want the area of the shaded region again. And we can see in this case, to get that shaded region, we're first going to work out the area for the whole triangle, and then we're going to take away that little bit of a circle we had. So we do the whole triangle minus the circle, and we'll be left with a shaded region. So for the triangle, we can use the formula a half AB sine C. In this case, we're not given an angle. However, we can see this is an equilateral, in fact we're told it, an equilateral triangle. That means all the angles are the same, and because they add up to 180, that means each angle here is going to be 60 degrees. So for my triangle, I'm going to do a half times 6 times 6 times sine of 60. Now I need to work out the area of this little circle sector. We are told that P and Q are the midpoints of AB and AC. Midpoints means they're exactly in the middle, which means they must both have a length of 3 centimeters. So for a circle, we're going to do pi r squared times by what fraction we have. So here the radius is only 3, and again we have 60 degrees in the circle, or the circle sector, so it's going to be 60 over 360. And we can just type that straight into a calculator to work out our answer. I won't go through that because I'm sure it's just work that anybody can do, just typing stuff straight into a calculator. I'm going to finish with one more exam style question. Okay, so it's the exact same idea, just looks a tiny bit different. So given that C is the midpoint of BD, so this is in the middle here, we need to find the area of the shaded region. And in this question you would also be told that this is a sector of a circle. That's important because that tells us that this length BD will also be 20 centimeters, and because C is the midpoint, that tells us this length will be 10 centimeters. And again, all these questions are the exact same idea. You basically find the difference between two areas. So here we have this sector, and we're then going to take away that triangle that's inside it. So for the sector, it's pi r squared times a fraction that we've got. So pi times 20 squared times 115 out of 360. Take away, we need the area of this triangle, and that's going to use the formula a half AB sine C. So again, that was 10, that was 20, and this angle is 115. So a half times 10 times 20 times sine of 115. Again, you can type it straight into the calculator, do it all in one go if you want to, and that will give you the area of this shaded region here. Okay, I hope that helped, and thanks for listening.